Greetings, everyone. Today we're going to explore intercepts. We're still talking about lines, but we want to find and graph intercepts. So let's talk about what an intercept is, first of all. The intercept is where I cross an axis. That's what that means. So when we cross an x-axis or a y-axis, then we have what's called an intercept. And think about that. When a player intercepts a ball, right? It's where it crosses that line, right? And it's taken to the other side. So try to connect it to the real world to help you remember that. Now, we do have a note sheet for this. It'll make it much easier to take notes. So please pause, make sure you have that before you get going. All right, I created some fill in the blanks here on your notes. So let's fill in this first part. The point where the graph crosses the x-axis. We're going to be specific because we're talking about the x-intercept. So it's in the name, cross the x. Now, algebraically, the x-intercepts happen when the y value is 0. Well, think about that, right? If I'm an x-intercept where I cross an x-axis, this would be like 3, 0. So that makes sense. Or what if I had a dot over here? That would be like -5, 0. The y value is always 0 if I'm on the x-axis. Now, here's where we're going to put a star by this. Here's your rule or your steps you're going to follow. To find the x-intercept from an equation, you're going to replace the y, or f of x, with a 0 and solve for x. Okay? So we're going to plug in a 0 and solve. That's what we're doing. Plug in a 0 and solve. So here's the first example. Now we created a little table. We're going to come back to it. Right now, what we're going to do is only find the x-intercept in this example, meaning the rule says to find the x-intercept, plug in 0 for y. So go put a 0 here and solve. So let's do that work. We're going to plug in a 0 for y, right? See how I left a space? And instead of a space, we're plugging in 0 for y. Maybe I should use a color here. That'll make it easier. Plug 0 in for y. See how I replaced it? And then we want to solve. But what is 4 times 0? 0. Adding 0 is not going to change anything. We get to cross it off on this one. 3x falls down, 24 falls down. How do I solve this? Instead of x times 3, let's divide 3. And you don't even have to show me anymore because you know x is going to be by itself. So what is 24 divided by 3? 8. X equals 8. Okay, let's jump to the other side of your notes. Let's talk about the opposite, the y-intercept. The point where the graph crosses the y-axis. See how it matches the name y-intercept across the y-axis? So let's talk about that. If I'm on the y-axis, this could be like 0, 2, and this could be like 0, -2. So what do you notice they have in common? The y-intercepts happen when the x value is 0. See how the x value is 0 in both of those? So let's put a star over here. Here's your rule. Here's your steps. To find the y-intercept from an equation, you're going to replace x with a 0 and solve for y. So let's try that. Let's go back to that same example here. Here's how I'm changing things. To find y, keep the y. I want to know the y. I don't want to know the x. So we plug a 0 in for x. So in our work, we're going to replace the x with the 0 and solve. See how I just filled in a single 0? Let's solve. Well, 3 times 0 is 0. I've got 4y equals 24. Instead of times +4, let's divide by +4. And y equals 6. y equals 6. So what we do is, this is just like our other tables, right? We have this point 0, 6 if we're going to write it out. All right, let's try to put it all together. This is how most of your problems will look to start off with, right? I care about plugging in 0 for one number and plugging in 0 for the other number. So let's set up our problem. I'm going to write my problem, but instead of x, what are we plugging in? 0. Let's solve. What's 5 times 0? 0. I've got negative 6y equals, oops, I forgot my 6 there, didn't I? I'm sorry. This should be 60. So instead of times negative 6, we're going to divide by negative 6. What's 60 divided by negative 6? Negative 10. Y equals negative 10. Let's take a look at the opposite. This time, we are going to, oops, sorry, I don't know what I was jotting down there. We're going to write the equation, but we're going to leave a space for y. And instead of y, I'm plugging in the 0. Let's calculate. What's negative 6 times 0? 0. I've got a 5x equals 60 left over. Instead of times 5, what do? Divide by 5. X equals 12. 12 is my x-intercept. Alrighty, let's put all of this together, the table and the graph. Everything we're doing is going to be a line. Here's how this is easier. You only have 2 dots. Look at that table. We're used to 5. We're only going to have 2. So let's start off with, if I plug 0 in for x. All right, so let's write our function. Everything stays the same, but instead of x, what am I going to put? A 0. Now this looks a little different. I can calculate a little bit here, right? What's 0 plus 1? 1. What's negative 2 times 1? Negative 2. What's negative 2 plus 4? 2. Y equals 2. Look at this is a dot. This is 0, 2. Let's go plot it. 0, 2. That's my Y-intercept. I had a Y number, so I have a Y-intercept. Let's try the opposite, meaning let's rewrite the function, but this time instead of y, I'm putting a 0. First step, distribute. Negative 2x minus 2. The plus 4 falls down. Let's combine like terms. What's negative 2 plus 4? Positive 2. Now we can solve for x. Minus the 2 to the other side, negative 2. The negative 2x falls down. I'm running out of room, I'm sorry. Instead of x times negative 2, let's divide both sides by negative 2. X falls down. Negative 2 divided by negative 2 is 1. So I've got this point, 1, 0. I'm going to go to the x. I have an x number, so I've got a dot here at 1. Look at that. Here's the cool thing, you guys. You only have 2 dots to connect with your line and arrow. Perfect, easy, only 2 dots. Let's try one more, okay? All right. I want to plug a 0 in for x to begin with. Again, the order in which you choose to solve this doesn't matter. I'm just putting the 0 in first. So I'm going to write my function. But instead of x, plug in a 0. Let's solve. Oh, what's 3 times 0? 0. What's 0 minus 6? Negative 6. That was way faster. At 0, negative 6, or on the y-axis at negative 6 is where I exist. Let's try it the opposite way. This time, we're going to plug 0 in for y. Plug 0 in for y. Oops, I'm going to color code it though. So instead of y, I leave a gap. And instead of y, I put a 0. Regular old solving to get x by itself. Instead of minus 6, let's kick it over by adding 6. Instead of x times 3, let's divide by 3. X equals 2. My x number is 2. My x-intercept is 2. 2, 0. We've got a nice, clear 2 points that I'm going to connect with a line and arrows on the end. So again, the overall concept. Plug in 0 for x and solve. Plug in 0 for y and solve. The goal is 2 dots, 1 on each axis. Okay? Make sure that you check Google Classroom to see what the task is to go with this video. Let me know if you have questions. Let me know if you need some support in the Sabre Center. And until next time, have a good one.